Automation is typically used for high quantity standardized products. So when we talk about automation, really we're talking about automation for the repetitive and the continuous process designs. When we talk about automated production, we're talking about using machinery or equipment with some kind of sensing and controlling devices so they can be operated automatically. So in a moment we're going to look at the different types of automation, but before we do that, let's look at some of the pros and cons of having automation within your company. So why would a company at all choose to use machines, robots that can operate automatically, okay, without humans having to do each piece? Well, one of the benefits is replicability. That is, we can make a particular good and every one of those units we produce should be the same because the machine is going to do exactly the same thing for every unit it produces. So for example, if we are Pepsi and we are filling Pepsi cans full of Pepsi, it should be putting in the exact same amount of Pepsi every time. Whereas if a person did it, there might be slight differences. So it's a way to maintain the level of quality. You get the same thing from every product. The other thing is that you can have machines do things that are repetitive, right? It's hard to get employees to want to do the exact same thing all day, every day, day after day after day. But machines are able to do repetitive tasks without that loss of enjoyment or that high turnover, right? The machine doesn't decide it's going to quit because it's bored. And they can do it rapidly. Right? So we can do repetitive tasks quite quickly. Now, the downside to having automation is these machines can be very expensive, and they are a fixed cost. So we have a much higher fixed cost. The other thing we have to consider is the impact that our automation has on the ability to do customization. How flexible or what impact does that have on the flexibility of the company? So if you remember back when we talked about the job shop used very general purpose equipment. If you are hand making shoes, then maybe it's a hammer. If you're hand making clothes, it's a sewing machine. If you are hand making, if you're at the hospital, right, then it's syringes, scalpels, and those types of things can be used for lots of different things. They can be used to adapt different types of surgeries and procedures, make different types of clothes, make different types of shoes. And so there was a lot of customization. Well, the more we automate the process, the harder it is to get that high level of customization. Although we'll talk in a moment about new steps that have been taken to try to increase the flexibility or customization that we can get with automation. But the other thing we have to consider as you look at automation is that there tends to be a general fear of automation, right? People are concerned that their jobs are going to be replaced by robots, right? Recently, we've been told that jobs like truck driving, that's going to be completely replaced within a couple decades by machines, right? So people are afraid they're going to be laid off, that their job's not going to be available because their company is adding additional mechanization. Well, this isn't a new phenomenon. In fact, if we go back to the Industrial Revolution, so if we're going back to the early 1800s, say like 1815 time period, back then people were afraid of being replaced by automation as well. There was actually a group called the Luddites, and the Luddites were afraid they were going to be replaced by machines. And so the Luddites, what they used to do is they used to sabotage the machines. And actually the word sabotage comes from the word sabot, which means wooden shoe. Well, why the English lesson? The the Luddites would take their shoes, their wooden shoes, and they would shove them into the machines, causing the machines to break. Well, if the machines broke, then you needed more workers and people didn't get laid off. This was such a big problem during the Industrial Revolution that if you were found guilty of sabotaging a factory or manufacturing process, you got the death penalty, right? The punishment was death. It was so severe. Well, what about today? People are afraid of automation today. People have been afraid of automation for hundreds of years. In the 80s, GM was being beat by Toyota, right? Toyota was producing better quality products and GM was just really suffering. And so GM started to look at, well, maybe we should automate our production processes. Let's replace our people with robots. So they bought all of this machines, and the problem with that, though, was that it ended up costing them way more money than just buying the machines. In fact, the cost to mechanize cost them $40 billion in the 80s. But flexibility and productivity at the business declined. So the idea of mechanization, it didn't work out so well in terms of profitability at the time. And the reason is because there were glitches in the original software, and so there were a lot of quality issues early on. There were issues in terms of the amount that could be produced because of breakdowns in the machines. You also had a labor strike in protest of people being replaced by machines, and so they were running at about 50% capacity after implementing all this automation. So it ended up being way more expensive than they had initially invested in it. So we got to weigh the advantages and the disadvantages of automation. And in a lot of industries and a lot of production, we are moving towards that level of automation. And so we're dealing with that fear that comes from the employee base at this time. So what levels of automation do we have? Well, when it comes to different types of automation, there are generally 3 types of automation. The first is what is called fixed automation. Fixed automation is where you have specially built equipment. It does a particular role, and everything happens in a fixed sequence of operations. So the equipment does one thing in the process. In this case, we're going to have a big fixed cost. We're going to produce a large quantity, and so we're going to lower the per unit cost. Now, when it comes to this fixed automation, it was really made popular by Henry Ford back in the 1900s. So this is the beginning of mass production. And so each machine had a particular purpose in the car manufacturing process, and it really couldn't be adapted to do anything else. We were just getting the cars through the process, through that fixed operation. Well, then came the idea of programmable automation. So with programmable automation, what we see is that we can make our machines smarter. So instead of having very specialized equipment, we can have more general purpose equipment, and we can put a computer chip inside of the machine and have a computer tell the machine what to do. This allows us to increase the variety a bit. So often what we're doing here is producing in batches. So we may have to reprogram the computer to change a bit of what it's doing, different specs for maybe a different model. So we're increasing the variety. Of course, it's going to decrease the quantity, but now we can change over what each machine does by having a computer programmed. So this is going to allow for a bit more variety or flexibility. So in order to do that, we need computers to control machines. And so we have what are called CNC machines, or computer numerically controlled machines. This is where our machines perform operations by following Mathematical processing instructions. So somebody is writing code to tell the computer, or telling the computer will tell the machine what to do. So we couldn't do this really until our machine started to contain computer chips. The benefit of this is that we can now do more precise work. So for example, if we have a laser cutter, then we can do much more detailed laser cuts because we can program exactly how it's going to cut into the machine and have the machine do it much more precisely than a human could do. Think, for example, about a 3D printer. In a 3D printer, you put into the software exactly what you want to design, and it can do all the edges and turns, that level of precision that you want. With CNC and programmable automation, we now require a bit higher skilled of workers. When you had fixed automation, you had low skilled workers. They were basically just putting materials in place so the machine could do a job. Now we need higher skilled workers because we need people who can program the equipment. And if we're going to have a changeover and so change from producing one model of car to another, then we need someone to program that in so that the machines know that the pieces they're holding are slightly different size, or they need to cut something slightly different. So we now need some higher skilled workers. So that brings us then to our third type of automation. So if we're looking, for example, at the history of Ford started with fixed automation. Each machine had a specific role, and it only did one thing. Then we switched to programmable automation, so now we have computers. We can program machines to do different things. The next step even beyond that is what is called flexible automation, and so this is to allow us to combine that programmable automation with increased flexibility. So now we can have even more variety when we're producing large quantities of items. So in this case, we're going to have a very customized equipment. So it is going to do special tasks, but it can also be programmed. So what we're doing is we're taking that programmable automation and we're allowing it to give us even more quantity and variety. The idea with this is that we're going to reduce that changeover time than we have with the programmable automation, because now we can have the computer send messages to another computer to tell it to change the code and do something slightly different. Whereas with the programmable automation, we had to have a worker come in and tell each machine to do something new. So we're creating as a flexible manufacturing system, which is a group of machining centers controlled by a computer with automatic material handling. So the big difference between programmable automation and the flexible automation is now we actually have a collection of CNC machines, and those CNC machines now talk to each other. So the flexible manufacturing system then is when we take our whole production process and we have all of our CNC machines talking to each other and working together. So we're essentially creating what is called computer integrated manufacturing. This is a system for linking a broad range of manufacturing and other activities through an integrated system. So what we have now is we are linking our order taking, our scheduling, our purchasing, our inventory management, our distribution, all of those different processes within the company are all talking to each other. So essentially, let's say that we manufacture a product, let's say for cafe press. So our job is to build the t-shirts and the mugs that that customers order. So customers place the order, our system then, the ordering system where they place it online, talks to our computers that says we need to now print this logo on 300 mugs. We need to print 20 t-shirts with these logos. So then that system talks to our scheduling system to say when should we start, when does that need to be done, pulls that image in, and that then communicates to our equipment to say, here's what you need to do this, and start stamping that image on the mugs, on the shirts. All of our processes, all of our systems talk to each other. You can see another example of that here. So this is Allied Signal. They make landing gear for airplanes. And it's a little hard to see on this picture, but there's a little trolley system right here. And then you have all these workstations. So as the landing gear get made, what happens is the computer integrated manufacturing, it takes the work in process to the next workstation. It tells the workstation what needs to be done. The work is done there, and then the work in process is loaded back on the trolley and then taken to the next workstation. So all of the systems are talking to each other, and so it can be moved from workstation to workstation, and production can be completed with all of our CNC machines talking to each other. If you've ever been on the main campus of Red Deer College, there's a Festo machine. Essentially, when you come in by the parking lot, that's the public parking lot on the trade side, as you look through that window, you'll see Festo equipment, and the Festo equipment is a computer integrated manufacturing system. We have a scale model, and Festo equipment is used by companies like Walmart for what is called cross-docking. That is when they bring all of their trucks up to a location, and all of the items are pulled off of one truck, they're sorted, they're inspected, and then they're put on to the other trucks. And so it reduces their warehousing costs because it's all automated, pulling material off one truck, checking it, and putting it onto other trucks. Festo equipment is also used by BMW in Germany to manufacture vehicles. It's been used by pharmaceutical companies to make caplets. And so it's very much like what you see with Allied Signal in terms of you have these little trolleys that take material from workstation to workstation, and it's all computer programmed to tell each workstation what to do once the material arrives. If we are comparing our different types of automation, so let's just make a little chart here. So we have our fixed, and we have programmable, and we have our flexible. Okay. So we can look at volume, or quantity, or capacity. Fixed is going to have the highest. And you see fixed automation with a lot of that continuous. So we're talking about steel manufacturing, we're talking about sugar, when we're making polyethylene, polypropylene, plastic pellets. It's all fixed. The machines are very specific, and they just keep churning through the materials and producing more output. They're very much going to use fixed automation. Where you're going to see programmable and flexible automation is more in that repetitive process, the mass production, and that's because the volume is going to be a little lower, and you're going to want a bit higher in terms of variety that's produced. So when we talk about a higher variety in terms of the amount that's produced, it's not anywhere near job shop or batch, but it's higher than it used to be for a repetitive process because those machines now talk to each other, because they can be programmed to do different tasks. We could look at another graph that kind of shows you that same trade-off. So here you have fixed automation with the highest capacity, and then you have your flexible manufacturing system, which gives you a little bit more variety. But then, of course, the standard and conventional machinery, that's your job shops with your very general purpose equipment on the other extreme.